This is the 2021 Stanford Math Tournament Number Theory section, and this is problem number 2. And we wish to find the smallest integer n greater than or equal to 2021 such that this polynomial is divisible by 13. So let's rewrite this polynomial. This is 30n cubed plus 143n squared plus 117n minus 56 and 3. And I want to reword this in terms of modular arithmetic, so let's just see this is congruent to 0 mod 13. Now our next step is to go and reduce the coefficients mod 13. We know 30 is congruent to 4 because 26 is a multiple of 13, and then we just subtract that from 30. So 4n cubed. 143 is a multiple of 13, that's 13 times 11, so that basically disappears upon division of 13. 117, same thing. 117 is 13 times 9, so that disappears among division 13. And then 56 is 13 times 4 plus 4, so this is just 4 mod 13. So minus 4 is congruent to 0 mod 13. So now we can see we can exploit a bunch of factoring tricks. We can factor the 4, and then we can use the cube formula. So we can do 4 times n cubed minus 1, which is equal to 4 times n minus 1, and then n squared plus n plus 1. And then this is congruent to 0 mod 13. Alright, so 13 is a prime number, so this 4 has no effect on the congruence. So we can either have that n minus 1 is congruent to 0 mod 13, in which case n is congruent to 1 mod 13 by just adding 1 both sides. Or we can have a little bit more complicated case, n squared plus n plus 1. In which case, I don't see any great way to do this other than maybe guessing and checking. We can start from n equals 0 to n equals 12, and then that's basically all the possibilities mod 13. So plugging in n equals 0, this fails. That's just 1. N equals 1 gives us 3, that's not mod 13. 2 gives us 4, 7. 3 gives us 9 plus 3 plus 1, which is 13. So 3 passes. 4 gives us 21. 5 gives us 25 plus 5, 31. 31. Alright. 6 gives us 36, 42, 43. 7 gives us 49, 56, 57. Not a multiple of 13. 8 gives us 64 plus 8, which is 72 plus 173. Not a multiple. 9 gives us 81 plus 9, 90, 91, which is a multiple of 13. 13 times 7. 10 gives us 111, which is not a multiple of 13. 11 gives us 121 plus 11, which is 132, plus 1 is 133, which is not a multiple of 13. It's congruent to 3 mod 13. And then 12 gives us 144 plus 12, which is 156, plus 1 is 157, which is not a multiple of 13. So we have the rest of our cases. N is congruent to 3 mod 13. And then n is congruent to 9 mod 13. Okay, so now we want to find the smallest n greater than or equal to 2021. So among these congruences, we want to find the smallest n that satisfies. So let's first look at the first congruence, see how many 13s are needed. To do that, we just do 2021 minus 1, which is 2020. And then let's go ahead and divide that by 13. See what our remainder is. So 13, that's 1, 13, 7, 2, 5, 65, 7, 0, 5, 65, 5. Okay, so we have that 2020 is 155 times 13 plus 5. Therefore, we have that 155 times 13 is 2020 minus 5, which is 2015. Alright, so 2015 is a multiple of 13. So we could have 2016. So for the first try, we can have 2016. We could have 2018, or we can have 2015 plus 9, which is 2024, which satisfies this constraint. Now, if we are to go another cycle 13, we see that we exceed 2024. Therefore, we can conclude that 2024 is the smallest such value that satisfies this, and we are done.